An electrical inspection form is a document used to record the findings of an inspection of an electrical system. It typically includes information about the property address, inspection date, inspector, and the scope of the inspection. The scope of the inspection often covers electrical distribution systems, lighting fixtures and switches, outlets and receptacles, grounding and bonding, and smoke and carbon monoxide detectors. The form also includes sections for noting any deficiencies observed in each of these areas and recommendations for addressing those deficiencies. Firstly, consider the electrical distribution system. Common deficiencies observed might include overloaded or undersized circuits, improper connections or terminations, damaged or missing insulation, defective circuit breakers or fuses, and incorrect grounding or bonding. Overloaded circuits occur when too much current is drawn on a circuit, potentially leading to overheating and fire hazards. Undersized circuits, conversely, may not be able to handle the intended load, causing breakers to trip frequently. Improper connections or terminations, such as loose wires, can create resistance, generating heat and increasing the risk of electrical fires. Damaged or missing insulation exposes conductors, posing a shock hazard. Defective circuit breakers or fuses fail to protect the circuit from overcurrents. Incorrect grounding or bonding can lead to electrical shocks and equipment damage. Secondly, examine lighting fixtures and switches. Deficiencies can include broken or damaged fixtures, loose or flickering bulbs, improper ventilation or heat dissipation, arcing or sparking, and faulty switches or ballasts. Broken or damaged fixtures pose a safety risk and may not function properly. Loose or flickering bulbs indicate loose connections or a failing bulb. Improper ventilation or heat dissipation can cause fixtures to overheat, reducing their lifespan and potentially causing a fire. Arcing or sparking is a sign of a dangerous electrical fault. Faulty switches or ballasts can cause lights to malfunction or fail completely. Thirdly, assess outlets and receptacles. Deficiencies may include broken or loose faceplates, worn or corroded terminals, loose or missing screws, overloaded or misused outlets, and inadequate grounding. Broken or loose faceplates expose live electrical components, creating a shock hazard. Worn or corroded terminals increase resistance, leading to heat generation and potential fire hazards. Loose or missing screws can cause outlets to become unstable and unsafe. Overloaded or misused outlets can draw excessive current, tripping breakers or causing overheating. Inadequate grounding provides no path for fault current, increasing the risk of electrical shock. Fourthly, scrutinize grounding and bonding. Deficiencies can involve missing or inadequate grounding wire, broken or loose ground terminals, improper grounding of metal fixtures and appliances, and reverse polarity or open neutral. A missing or inadequate grounding wire prevents fault current from safely returning to the source, increasing the risk of electrical shock. Broken or loose ground terminals compromise the grounding path. Improper grounding of metal fixtures and appliances can energize these objects in the event of a fault. Reverse polarity or open neutral conditions can cause equipment to malfunction or become dangerous. Fifthly, evaluate smoke and carbon monoxide detectors. Deficiencies may include missing or malfunctioning devices, low batteries or failed sensors, and improper placement or mounting. Missing detectors leave occupants vulnerable to fire and carbon monoxide poisoning. Malfunctioning devices fail to provide adequate warning. Low batteries or failed sensors render the detectors ineffective. Improper placement or mounting may prevent the detectors from detecting smoke or carbon monoxide effectively. Recommendations for addressing these deficiencies typically include replacing or repairing defective components, adding additional circuits or outlets, ensuring proper grounding and bonding, installing smoke and carbon monoxide detectors where necessary, and contacting a qualified electrician for repairs or upgrades. Replacing or repairing defective components eliminates safety hazards and restores proper functionality. Adding additional circuits or outlets alleviates overloaded circuits and provides adequate power for appliances and equipment. Ensuring proper grounding and bonding protects against electrical shock and equipment damage. Installing smoke and carbon monoxide detectors where necessary provides early warning of fire and carbon monoxide hazards. Contacting a qualified electrician for repairs or upgrades ensures that the work is performed safely and correctly. Furthermore, a detailed electrical inspection form might include specific sections for checking the condition of the service entrance, panel boards, and branch circuits. The service entrance is where the electrical power enters the building. An inspection of this area would involve checking the condition of the service conductors, meter, and main disconnect. The panel board is the distribution point for the electrical circuits. An inspection of the panel board would involve checking the condition of the breakers, wiring, and grounding. Branch circuits are the individual circuits that supply power to outlets, lights, and appliances. An inspection of the branch circuits would involve checking the condition of the wiring, outlets, and fixtures. Specific items to look for during an electrical inspection of the service entrance include 1. Proper size and condition of service conductors. The service conductors must be sized appropriately for the electrical load of the building. They should be free of damage such as cuts, abrasions, or corrosion. 2. Secure and weathertight connections. All connections at the service entrance must be secure and weathertight to prevent moisture from entering the electrical system. 3. Proper grounding of the service entrance. The service entrance must be properly grounded to protect against electrical shock. This typically involves connecting a grounding electrode conductor to a metal water pipe or ground rod. 4. Presence of a main disconnect. A main disconnect is required to shut off all power to the building in case of an emergency. 5. Correct labeling of the service entrance equipment. All service entrance equipment should be clearly labeled to indicate its purpose and function. Specific items to look for during an electrical inspection of the panel board include 1. Adequate capacity of the panel board. The panel board must have sufficient capacity to accommodate all of the circuits in the building. 2. Proper size and type of circuit breakers. The circuit breakers must be sized appropriately for the circuits they protect. They must also be of the correct type for the panel board. 3. Secure and properly connected wiring. All wiring in the panel board must be secure and properly connected. Loose or corroded connections can cause overheating and electrical fires. 4. Proper grounding of the panel board. The panel board must be properly grounded to protect against electrical shock. 5. Correct labeling of the circuit breakers. All circuit breakers should be clearly labeled to indicate the circuits they protect. 6. Absence of any signs of overheating or damage. The panel board should be free of any signs of overheating, such as discoloration or melted insulation. Specific items to look for during an electrical inspection of branch circuits include 1. Proper wire size for the circuit. The wire size must be appropriate for the amount of current the circuit will carry. Refer to the National Electrical Code, NEC Table 310.15b16 for allowable ampacities of insulated conductors. 2. Proper type of wiring for the application. The type of wiring must be suitable for the environment in which it is installed. For example, wiring installed in damp locations must be rated for wet environments. 3. Secure and properly connected wiring. All wiring connections must be secure and properly connected. 4. Properly installed outlets and switches. Outlets and switches must be properly installed and securely mounted. 5. Properly grounded outlets and switches. Outlets and switches must be properly grounded to protect against electrical shock. 6. Absence of any signs of damage or deterioration. The wiring, outlets, and switches should be free of any signs of damage or deterioration, such as cracks, breaks, or corrosion. In addition to these specific items, an electrical inspection form should also include a section for noting any other observations or concerns. This section can be used to document any potential hazards or problems that are not specifically covered in other sections of the form. An electrical inspection form should also include a disclaimer stating that the inspection is limited in scope and that it is not a guarantee of the safety or reliability of the electrical system. The disclaimer should also state that the inspector is not responsible for any damages or injuries that may result from the use of the electrical system. It is important to remember that an electrical inspection is only a snapshot in time. The condition of an electrical system can change over time due to factors such as age, wear and tear, and environmental conditions. Therefore, it is important to have electrical systems inspected on a regular basis to ensure that they are safe and in good working order. An example of a deficiency observed in an electrical distribution system might be an overloaded circuit. This can be identified by checking the amperage draw on the circuit with an ammeter and comparing it to the circuit breaker rating. If the amperage draw exceeds the breaker rating, the circuit is overloaded and needs to be addressed. This might involve adding a new circuit or reducing the load on the existing circuit. An example of a deficiency observed in lighting fixtures and switches might be a broken light fixture. This can be identified by visually inspecting the fixture for any cracks, breaks, or other damage. If a fixture is broken, it should be replaced to prevent electrical shock or fire hazards. An example of a deficiency observed in outlets and receptacles might be a loose outlet. This can be identified by wiggling the outlet and checking for any movement. If an outlet is loose, it should be tightened or replaced to prevent electrical shock or fire hazards. An example of a deficiency observed in grounding and bonding might be a missing grounding wire. This can be identified by visually inspecting the wiring for the presence of a grounding wire. If a grounding wire is missing, it should be installed to protect against electrical shock. An example of a deficiency observed in smoke and carbon monoxide detectors might be a malfunctioning smoke detector. This can be identified by testing the detector with a test button. If the detector does not sound an alarm, it is malfunctioning and should be replaced. The electrical inspection form should include spaces for the inspector to sign and date the form, as well as spaces for the property owner to acknowledge receipt of the form. The form should also include a space for the inspector to provide contact information in case the property owner has any questions or concerns. The note at the end of the sample form highlights the ability to customize the form, emphasizing its adaptability to the specific requirements of different businesses or inspection scenarios. This is crucial because electrical systems vary significantly across residential, commercial, and industrial settings. The specific elements that need to be inspected and the criteria used to evaluate them may differ depending on the type of property and the intended use of the electrical system. For example, an inspection of a commercial building might focus on different aspects of the electrical system than an inspection of a residential home. Customizing an electrical inspection form involves several steps. Firstly, the inspector needs to identify the specific areas and components that need to be inspected based on the type of property and the purpose of the inspection. Secondly, the inspector needs to develop a checklist of items to be inspected for each area or component. This checklist should be comprehensive and cover all of the key aspects of the electrical system. Thirdly, the inspector needs to develop a system for recording the findings of the inspection. This system should be clear, concise, and easy to use. Fourthly, the inspector needs to develop a set of recommendations for addressing any deficiencies that are identified during the inspection. These recommendations should be specific, actionable, and cost-effective. Fifthly, the inspector needs to obtain the necessary tools and equipment to perform the inspection. This might include items such as a voltage tester, an ammeter, a ground resistance tester, and a thermal imager. Sixthly, the inspector needs to be properly trained and qualified to perform electrical inspections. This might involve completing a formal training program or obtaining certification from a recognized organization. By customizing an electrical inspection form and following these steps, inspectors can ensure that they are performing thorough and accurate inspections that meet the specific needs of their clients. This can help to improve electrical safety, reduce the risk of electrical fires, and protect property and lives. When conducting an electrical inspection, consider the age of the electrical system. Older electrical systems may have outdated wiring, components, or safety features that do not meet current standards. These systems may be more prone to problems such as overloaded circuits, loose connections, and faulty grounding. It is important to carefully inspect older electrical systems and identify any potential hazards or deficiencies. Also consider any recent renovations or additions to the property. Renovations or additions can sometimes introduce new electrical loads or modifications to the existing electrical system. It is important to ensure that any new electrical work is performed in accordance with applicable codes and standards and that it does not overload the existing electrical system. Consider any unusual or suspicious conditions. Be alert for any unusual or suspicious conditions, such as flickering lights, sparking outlets, or burning smells. These conditions may indicate underlying electrical problems that need to be investigated further.